All right, boys and girls, welcome back for a little 5-minute lesson on probability. This is 12-1. Okay. The probability that something will happen is the amount or the number of successful outcomes divided by the total possible number of outcomes. So this means that a probability can never be less than 0 and can never be more than 1. Okay. You can express probabilities anyway. I'm an equal number lover. All right, so today's lesson is just going to be pretty vocabulary based. So mutually exclusive events. Those are two things that cannot both happen. Think about heads or tails. You cannot have a head and a tail. It's one or the other. Okay, so if we have mutually exclusive events, or makes probabilities more likely. Okay, what's the probability that I toss a head or a tail on this coin toss? Oh, well, that's 100% because you're adding. You're just adding. So the probability of A or B is the probability of A plus the probability of B. And again, that's only true for mutually exclusive events. We'll go into the other scenario later. Also, therefore, it means if A and B are mutually exclusive, then the probability of A and B is 0. So again, what's the probability that I toss a coin and I get a head and a tail? 0. Okay. Now, this is a new use of the word complement. In statistics, the complement of an event is the set of all outcomes that are outside of the desired sample space. So, I don't know. If it's like, what's the probability that I select somebody for my geometry class and they are a sophomore? Okay, well, there's that probability. Well, the complement of that event would be that they are not a sophomore. And specifically in our class, it would probably mean they're a freshman. But you'll notice what it says right here is the probability of a complement. Sorry, I'm trying to get the probability of a complement is 100% 1 minus the probability of the event, meaning that the event and the complement have to add up to 100% likelihood. Okay, told you, just a lot of vocabulary today. Okay, now, if A and B are not mutually exclusive, then that means you could have people or items that were part of both groups. So think about, what if I said, what's the probability that someone in our geometry class plays a sport for Sycamore? That there would be an answer to that. Well, what's the probability that somebody in my geometry class plays an instrument? There'd be a probability for that. However, there would almost certainly be a group of people that do both, that play both a sport and play an instrument. And there you can see that in the overlapped part of the Venn diagram, okay? So if we do the probability of A or B in this instance, we have to do the probability of A plus the probability of B, and then we have to subtract the probability of A and B. So what are we doing? Well, we're taking all of the people that play sports, and then we're taking all of the people that play an instrument, and we're adding them. But then we are subtracting out the people that play both because we counted them twice. We don't want to count them twice. And if you do that, that's how you get the probability if two events are not mutually exclusive. That's kind of a big one. That'll almost certainly be on your OST. Okay, now, if we have two events that are independent, that means one event has no likelihood of affecting the other event. Okay, so these are not mysterious connections at a distance. They're completely non-connected. Okay, so for example, rolling a dice has nothing to do with tossing a coin. They're independent events. If two events are independent, then the probability of A and B happening is simply the probability of A times the probability of B. Now, oftentimes in math, when we multiply, things get bigger, but in probability, when we multiply, things get smaller. The fact is, and makes things more difficult because both events need to happen. If your parents told you that you need to clean your room or eat a snack, you would not have to clean your room. You'd have the option. If your parents told you to clean your room and eat a snack, you would have to clean your room. And makes things more difficult. If you've heard of parlays, and is what makes something a parlay. Okay? All right, now the converse of this is also true. So if the probability of A and B is calculated by the probability of A times the probability of B, then you know that A and B are independent events. Sometimes they use this as a little sneaky word problem. Okay, so let's look at the example. When rolling a die and tossing a coin, the result of the die roll and the result of the coin toss are independent events. What's the probability of tossing a 4 and a head? Well, there's only 1/12 a likelihood of this happening. Okay, the probability of tossing a 4 is 1/6. The probability of tossing a head is 1/2, and therefore the probability of simultaneously rolling a 4 and tossing a head is 1/12. Boink. Boink. And that's it. Boom.